Okay, hi everybody. We're going to wrap up section 12.3 today. If you remember from the lesson a couple days ago, we were kind of plotting a point and making these triangles in the coordinate plane rather, and then we would do the Pythagorean theorem so that we knew all three sides of the triangle, and then we would set up our 6 trig functions. This is going to be similar to that, but some of the information that we're starting with is a little bit different. So a couple key things from the previous lesson that will hold true in today's lesson is once we have our triangle made, we always want to place the theta symbol inside the triangle, but it needs to be placed inside the triangle so that it's at the angle closest to the origin. Okay, the other thing that we also want to keep in mind is that no matter which quadrant our triangle lands in, the legs might be labeled as negative, but the hypotenuse is always going to be positive. Okay, that'll be very important. So I've got some steps here to kind of help us with this, to sort of walk through these examples here. And so I'm going to reference these steps as we kind of go through these examples, because when you read the actual problem, it sounds very complicated. It says, suppose theta is an angle in standard position whose terminal side is in the given quadrant. So you can see down here that they name a specific quadrant. So instead of giving us a point, they're naming a quadrant where the terminal ray is landing in, but not telling us specifically a point it's going through. It says, for each function, find the exact values of the remaining 5 trig functions for theta. So they're giving us one trig function. They're giving us that sine is the square root of 2 over 2, which obviously we would be able to fill in cosecant. Okay, but here's what we're going to do to begin with. We're going to plot a point. Okay, we don't know specifically what the coordinates are, but we're going to plot a point in the quadrant that they're naming for us. And in this problem, they're naming quadrant 1. Okay, so once again, just keep in mind that we're kind of thinking of this in terms of angles. So the initial side rather, is always going to be on the positive side of the x-axis here. Okay, when it says quadrant 1, all you're going to do is, it doesn't really matter even where you put the point. Just stick a random point anywhere in quadrant 1. Don't make any markings on the xy axis. And you're then going to draw a perpendicular line from that point, but it has to be to the x-axis. So just drop it down to the x-axis. Okay, then you're going to connect that point to the origin, and this will complete your triangle. Okay. We are going to place the theta symbol at the origin. Okay, so you're going to put a little theta symbol right in there at the origin. Okay, and then we're going to label 2 of the given sides of the triangle. Okay, now before we did that because we had a point, and so the points were kind of the 2 legs of the triangle. Here this is going to be a little bit different. How we know 2 sides of this triangle is because the problem is giving us a trig function here. Okay, we know that sine is opposite over hypotenuse. So they're really telling us 2 sides of this triangle when they give us this fraction here. Okay, so we're going to label the opposite leg of where our theta symbol is. That would be this leg right here. That's going to get labeled square root of 2. The hypotenuse is going to be labeled 2. Okay, so when we do the Pythagorean theorem for this, we are not finding the hypotenuse. I'm just going to call that missing leg x. Okay, again, I'm asking that you at a bare minimum show the initial substitution for the Pythagorean theorem, but this is going to require us to solve for this x here. Now keep in mind, when you square a square root, like here we're squaring the square root of 2, that just gives you 2. Okay, it gets rid of the square root symbol. Okay, and then we have to move that 2 to the other side of the equation. So that's going to be a 2 here, and then we're going to take the square root of both sides. And we end up getting that this other missing leg of the triangle was also a square root of 2. Okay, so once we have all the sides, then we can go back through and we can easily just kind of fill in each of these other ratios. And again, I'm not really going to talk through that let's see here. This was, yeah, okay. And this will be 2 over square root of 2. And tangent is opposite over adjacent, which would be square root of 2 over 2, which I should just write that as 1. And the reciprocal of 1 is 1. Okay, this is how 1 looks as a fraction. And if you flip that, it still looks exactly the same. Okay, so let's try another one here. Okay, you'll notice in this problem, we're going to start this out. We're going to draw an XY axis. Okay, we're going to look at what quadrant did they name. Okay, they named quadrant 2. So if we look at our steps here, quadrant 2 is over here. So I'm going to put a point anywhere in quadrant 2, and then I'm going to drop a perpendicular line, or segment rather, from that point to the x-axis, and I'm going to connect that point directly to the origin. I'm going to place the theta symbol at the angle closest to the origin, and then I'm going to look at the trig function I'm given. Okay, and this is where we want to start getting comfortable with knowing, okay, secant, that's the reciprocal to which trig function? Well, that's the reciprocal to cosine. So if cosine is adjacent over hypotenuse, then that means this is hypotenuse over adjacent. Now, here's where you're going to have to be careful. Remember what we said up above here. We said that the hypotenuse is always positive. So be careful. You know, when they have this negative in front of the 8, it doesn't necessarily mean that the 8 is negative. You know, you can write the fraction negative 8/3 the way that it's written there. You could write it this way and put the negative in the denominator. So when we think of this here, that 8 is the hypotenuse. I have to make that positive for the hypotenuse. That means this negative is really needing to go down with the 3. And when you label the adjacent leg as being -3, that should look like it makes sense, because look at where that horizontal leg of your triangle is at. It's on the negative side of the x-axis. Okay, anytime a horizontal leg is on the negative side of the x-axis, then that side of your triangle should be labeled as negative. And anytime a vertical leg, which was not the case here, but if a vertical leg is on the bottom part of the y-axis, then we would want to label that as being negative as well. Okay, so I'm going to go through, I'm going to set up the Pythagorean theorem. Okay, again, we're finding a missing leg. So we're going to set it up this way. Whoops. Okay, that's squared. Okay, and then we're going to solve for this missing leg. It looks like we end up getting x squared equals 55. So the missing leg is square root of 55. When you find these missing sides, add it into your picture, because sometimes when you add it to your picture, you realize that you need to make it negative. Now, in this example, that vertical leg is on the positive side of the y-axis, so I do not need to make the square root of 55 a negative. Okay, so I'm just going to, and again, I'm really sorry about what little space you kind of have here for this, but I'm just going to kind of build these fractions. Cosine is adjacent over hypotenuse, and this would be the reciprocal here, and then we've got opposite over adjacent for tangent. Okay, so let's look at the other one here on this page. Okay, once again, we're going to make an y-axis. We're going to look at the point, we're going to look at the quadrant they named. Okay, remember this is quadrant 1, 2, down here's 3, this is 4. So I'm going to put a point somewhere in quadrant 3. I'm going to draw a perpendicular segment from that point to the x-axis and also directly to the origin, and then I'm immediately putting the theta symbol in. Okay, I'm now going to look at the trig function they gave me, and I'm going to dissect what they're telling me here. Tangent is opposite over adjacent. So that's telling me the opposite leg to theta. I'm going to label it as a 4 for right now. The adjacent leg is 3, but I want you to look at this picture. I really should not be labeling this as 4, and I really should not be labeling this as 3. See how this vertical leg is on the bottom half of the y-axis? It is up to me to make that 4 a negative when I add it to the picture, and that is why it is absolutely crucial that you guys are drawing these pictures when you're doing these problems. It is unacceptable for you to simply do the Pythagorean theorem and write down what your fractions are. I have to see these pictures. Here's a great example of how when you add these to the picture, even this horizontal leg, you can see how the 3 is on the negative side of the x-axis. Those should both be negative. Now, why weren't they negative when the fraction was presented to you here? Well, because when we make a fraction, if both of the numbers are negative, then that just makes the fraction become positive. Okay, that's why we didn't really see either of them as being negatives to begin with. Okay, we would set this up, Pythagorean theorem. This is going to come out to where we're finding the hypotenuse. The hypotenuse would come out to be a 5. Please remember, the hypotenuse, however, is always positive. Okay, you never make that negative. And I'm just going to throw these fractions in here real quickly. Okay, we're going to look at one last problem here on the back. Okay, one last problem. And here's another good example, if I could draw this to your attention. On the example D that I did for you, see how I went through the Pythagorean theorem? I got that missing vertical leg to be the square root of 56, but then I realized when I add it to the picture, because the vertical leg is on the bottom half of the y-axis, it was up to me to make that negative, so that in some of these fractions I'm setting up, those values of those fractions should be negative. Okay, last one we're going to look at here is we're going to take a look at this one that's a cosecant problem. Okay, so we're going to start with what's the quadrant? It's quadrant 3. I'm going to put a point there. Got my perpendicular segment to the x-axis. I'm connecting that to the origin. I'm placing theta at the angle closest to the origin. Okay, the next question I'm asking myself is, what is cosecant a reciprocal partner to? Okay, it is the reciprocal to sine. Okay, well, I know sine is opposite over hypotenuse, so that means this is hypotenuse over opposite. Now, it would be really easy to miss this. You see this little negative that's floating right there? That means I have to decide, is that negative going to go with the hypotenuse, or is that negative supposed to go with the opposite leg? Okay, well, we know the hypotenuse is never supposed to be negative, and it should be obvious when we add these to the picture that the opposite leg should definitely be negative. Okay, so let me add, the hypotenuse is going to be 12. The opposite leg would be this leg over here, and it makes complete sense that that should be negative because that vertical leg is on the negative side of the x-axis. Okay, so I'm going to do the Pythagorean theorem. I'm finding a missing leg. Okay, so when we square these numbers off here and we work this out to try to solve this for x, it looks like we're going to have that to initially we get the square root of 95. Okay, however, when I come over here and I add it to the picture, I realize that that really should have a negative placed in front of it because this horizontal leg is sitting on the negative side of the x-axis. Okay, so you always compare the horizontal legs to the x-axis and the vertical legs to the y-axis. Okay, and then we would set up our fractions as we have been here. So I will just give those to you so that you have those. Okay, I hope that this makes sense. If you have questions, please just let me know. Let's see here, tangent, that's opposite, oh, over adjacent. Looks like that should not be negative because it would be 2 negatives there. Okay. Okay, opposite over adjacent. Yep, okay. All right, so I think that brings this to a close. We'll be looking at probably doing a review sheet very early next week in preparation for some type of an assessment over 12.1 to 12.3. Okay.